Good morning to all. So, in today's session, we will continue discussing the process module and one of the important aspect of the process module, that is process scheduling. So, in the last week, we have seen that process is nothing but a program which is currently in the execution. Process can be described through a data structure called PCB or process control block. The process control block contains various informations like process ID, state of the process, the register details about the process, owner of the process, permission of the process, and so on. Apart from that, if we talk about the behavior part of the process has multiple states in which it can go as per the time and as per the various events in the operating system. Some of the commonly encountered states are ready state, running state, block state, suspended state, etc. Now, in the multi-programming system, so we are talking about multi-programming system as well as the uniprocessor system. So see these two aspects. Multi-programming means at one point of time, we have multiple processes in our main memory that are ready to run. Uniprocessor means we have only single processor. We have only single processor on which one of these process can execute. So your question is that out of all these ready processes that you see in the main memory, which process you should schedule on the processor and in which manner it should be done. So this decision of scheduling a ready process from the main memory to the processor is called process scheduling, and it is what we are going to see in today's session. So depending on the different algorithms, you can have different scheduling policies, which we will see as we move on. So this is the basic idea of the process scheduling. This we have already seen in the last lecture. So I'll skip this part. Now we'll start from here. So when you do the scheduling, you can do your scheduling at three different levels. You can do the scheduling at three different levels. The first level is called long-term scheduler. So second level is called mid-term scheduling, and the third level is called short-term scheduling. So what is the meaning of long-term, mid-term, and short-term scheduling? So see, this concept of process scheduling is about admitting your ready process from the main memory to the processor. But apart from that, also a it is a concept which is involved in taking more complex decisions. So let's take a very non-technical example to understand these levels of scheduling. So let's say there is some event going on in your university, in some classroom, some event is going on, and there is a participant who is coming from some other city to your college. So what he will do is he will first reach the main gate of the university. So when he reaches the main gate of the university, there will be one coordinator who will tell him that, okay, you want to attend this particular event, so you can go to computer department, you can go to CS department. So that is the example of long-term scheduling. That is the example of long-term scheduling. The second level is now that person is reaching the main gate of the computer department, computer science department. The main building was of CH department. So at that location, you have another coordinator who will guide him that, okay, you want to attend this event, so you go to room number 102, for example, right? So that is second level of scheduling, called midterm scheduling. And now that person will go to room number 102. When he reaches the entrance of room number 102, one more coordinator is there who will tell him that, okay, wait here, and uh, I will tell you when there is a uh, when the event is going to start. I will send you inside. So that is the third level of scheduling. That is the short term scheduling, right? So you can see that all of the coordinators, uh, the one who is standing at the main gate of the university, the one who is standing at the main gate of CS department, and the one who is standing near the classroom, all of them are doing the same job, right? They are helping the participant to go inside the event room, but they have different levels, right? They have different levels. So this is a very rough analogy with what actually means when we talk about long-term, mid-term, and short-term scheduling. So let us see in terms of process, in terms of process scheduling, what is long-term scheduling? So see, the long-term scheduling is the decision of adding the process to the pool of processes to be executed, right? So initially, there are many processes in the system which are created, and there is a pool of process which are to be executed, right? Now your process, whichever process is created, should you add your process to the set of processes which are going to be executed later on? If yes, then that is the job of long-term scheduler. That is the job of long-term scheduler. So long-term scheduler comes into picture in the first stage. When the process is created, it will be sent to the pool of executing processes by the long-term scheduler. That is the first scheduling level. The second level is mid-term scheduler. The second level is mid-term scheduler. What is the meaning of mid-term scheduler? So, as you know that the process keeps on changing its state from running to suspended and suspended to ready or suspended to running. Means there are two things. Either the process is in the memory or the process is out of the memory. So the decision to add the process in the memory or to swap the process out of the memory, that decision is taken by this level of scheduler, that is called mid-term scheduler. And the third level of scheduling is called short-term scheduler. So short-term scheduler is the actual scheduling. So you can see that the decision as to which available process will be executed by the processor, it will be taken by short-term scheduler. So when you are actually allocating your process to the processor, that decision should be taken by the short-term scheduler. Okay. And there is also fourth level of scheduling. There is IO scheduling that takes the decision as to which process pending IO request shall be handled by the available IO device, right? So you know there are pool of IO devices. There are pool of IO devices, and there are some pending requests. So which request should be given to the which IO device? That decision is taken by IO scheduler. So in general, these are the levels of scheduling. Let us see in more intuitive way. So I think now you can understand in a proper way. So when the process is in the new state, when newly created process is there, whether to add the process in the ready suspended state or in the ready state, it is the decision which is taken by long-term scheduler, right? It is the decision which is taken by long-term scheduler. So long-term scheduler will add your process So you have to just remember that when the process is created for the first time, the long-term scheduler will come into picture, right? When the process is created for the first time, the long-term scheduler will come into picture, and it will put your process into ready suspended or ready state. Now from ready suspended to ready, or from block suspended to block, or even from ready to ready suspended, these all things are done by midterm scheduler. These all things are done by midterm scheduler, right? So when the process is ready, but let's say for some time the process is not able to execute, and due to memory problems, it has to go out of the memory. So this swapping is done by midterm scheduler. So basically swap in or swap out operation, wherever you see swap in swap out operation, is always done by midterm scheduler. Okay, you already know what is swap in and swap out, right? When we bring some process in the main memory, it is called swap in, and when we bring some process out of the main memory, it is called swap out, right? So in this way, we can use midterm scheduler, and the final scheduler is short-term scheduler. So you can see that there is only one use case when the process has to go from ready to running, right? So you can see this is a processor, right? This is a processor. So when the process has to go from ready to running, it will be done through the short-term scheduler. It will be done through the short-term scheduler. So frequency wise, if I ask you that which scheduler is invoked very frequently, so you can say short-term scheduler is invoked very frequently. Okay, short-term scheduler is invoked very frequently. Mid-term scheduler is invoked in the medium range of frequency, and the long-term scheduler will be invoked very rarely, right? Why very rarely? Because it will come into picture only when there is a new process created in the system, right? Which is not that frequent. Okay, when the new process is created in the system, at that time the long-term scheduler will come into picture. So it will execute, it will come into picture very rarely. Then mid-term scheduler and then short-term scheduler will come in the picture very frequently. So these are the levels of scheduling. So again, clarifying the schedulers. So the long-term scheduling is performed when a new process is created, as I told you. This is the decision whether to add a new process to the set of executing processes or not, right? So whether you want to run your process or not. When you create a new process, you have to take a decision that whether I want to actually execute this process or not. So it is dependent on the long-term scheduler. The mid-term scheduler, you can see the part of swapping function, right? The part of swapping function. It means that whether to swap the process out of the memory or to bring the process in the memory, this kind of decision is taken by mid-term scheduler. And finally, the short-term scheduler. Finally, the short-term scheduler is the actual decision of which ready process to execute next. Right? Short-term scheduler is which process you have to execute next. So all these schedulers are acting on different levels, and accordingly we have to understand. So again, this is one more illustration of the levels of scheduling. So as you can see, the long-term scheduler is kind of at the outer levels. Here you may see the long-term scheduler in the outer levels, because it will take only decision when to create a new process, when to exit the current process. So that is the decision of the long-term scheduler. So the mid-term scheduler is taking the decision of suspending the process and then basically bringing the process out of the memory and bringing the process in the memory. So that kind of decision is taken by the midterm scheduler. And finally, when the process is actually running, it is done through the short-term scheduler. It is done through the short-term scheduler to actually execute the process on the processor, and from basically from ready to running and running to block and vice versa. All these transitions are done through the short-term scheduler. So these are the three levels of scheduling which we understand. Okay. Again, you can see this is a kind of queuing diagram of what happens in the processor. So as you know, the state diagram that you have seen in the previous slides, in the previous sessions. So actually the state diagram is implemented through queue. So each of these states will be converted into queue. So we start from this uh, queue basically. Let's say this is number 1. The new process is created, so it will be entered into the batch of jobs which are ready in the system, which are created in the system, will be added in this pool. Then the long-term scheduler will decide that which process out of this queue, which process should be kept in the ready queue, which process should be kept in the ready queue. So this is a ready queue, which will be the set of processes which are in the memory. This set of processes are in the memory and they are ready to execute. As soon as the processor is free, they are ready to execute. And once the processor is available, the short-term scheduler will schedule it to execute it on the actual processor. Then when it is running, after some time, it has to wait, right? It may have to wait due to some reason, due to IO request or any other event, it has to wait. So this is 4 number, it will wait. So it will be in the block queue again. Now from the block queue, there are two possibilities. Either it will move to the ready queue again when the event happens. When the event happens, it will be moved to ready queue again. This is first possibility. Second possibility is it will go into block suspended queue. It will go into block suspended queue. So when it goes into block suspended queue, when this block queue becomes full, because this block queue is also in memory, right? This block queue is in the memory. So when memory becomes full and new processes are continuously coming, right? New processes are continuously coming. So it has to swap some process out and then it will go to the block suspended queue. So basically it is swap out operation. That's why it is done through midterm scheduler. That's why it is done through midterm scheduler. From block suspended queue again, when the event occurs, it can go to the ready suspended queue. It can go to ready suspended queue. It means that now the event has occurred and the process is no more waiting, but it is out of the memory, but it is ready to execute. So from there, it will again go into ready state. It will again go into ready state through midterm scheduler. So you can see that long-term scheduler comes into picture only once. Short-term scheduler also comes into picture only once, but it comes into picture very frequently because you have to frequently run the process and swap in and switch the process, right? Whenever there is a change here, short-term scheduler will be invoked. Whereas the midterm scheduler, as you can see, it comes into picture through all these waiting and block states. block suspended, block ready suspended states. So if you want to move your process between these states, you have to use the midterm scheduler, right? So this is in general queuing diagram of the process execution, and it is very helpful. This is a very fundamental thing which you should understand, and it kind of highlights the entire execution cycle of the process and entire behavior of the process, which kind of behavior the process will show during the particular events. So again, what is long-term scheduler? So long-term scheduler determines which programs are admitted to the systems for processing. Thus, it controls the degree of multi-programming. So this statement is very popular uh, in the literature, and also many times asked in the exam, that justifies why we say that long-term scheduler is controlling the degree of multi-programming. So why? Because uh, why long-term scheduler controls degree of multi-programming? Because if the long-term scheduler comes into picture, it will add one new process in the system, or it will remove one new process out of system. What is the meaning of degree of multi-programming? Basically, degree of multi-programming means number of number of processes active in the system. Number of active processes in the system. So that is determined by the long-term scheduler, that how many processes will be active at certain time period, and that kind of information is maintained by the long-term scheduler, and that's why it is said that's why it's being said that the long-term scheduler controls the degree of multi-programming. So decision, uh, I mean, how will you take the decision whether you want to add a new process to the memory or not, whether you want to create a new process or not? So a decision as to when we should create a new process is generally dependent on the degree of multi-programming, right? So if you are keeping a higher degree of multi-programming, it means more processes will be there in the memory. If you are keeping degree of multi-programming lesser, then less number of processes will be there in the memory. So all these decisions are taken by the long-term scheduler, right? All these kind of decisions are taken by long-term scheduler. So uh, this kind of decision is either on FCFS basis. It means that if you have 5 processes which are there in the system, then which process you should put it in the pool of the executing processes. So it depends on the various factors, like it may be FCFS based decision. It means whichever process came first, that will be executed first, or it may be driven by the other criteria, such as priority, expected execution time, and IO requirement. It means that what is the meaning of priority? It means that each process is defined some priority, and higher priority processes will be executed first, and lower priority processes will be executed later on. So either you have this kind of priority based mechanism, or you have the expected execution time. It means the process which is going to finish early right? The process which is going to finish early, you can keep that process, that process can execute first, and the long processes can execute later on. So that may be one of the criteria. IO requirements. So if the process requires more IO, it can be delayed. So all these criteria are used in deciding the long-term scheduling policies. For interactive programs in the time sharing environment, process creation request can be generated by the act of attempting to connect a new user to the system, and it should be the request of the user should be fulfilled immediately in the interactive system. Because what is the meaning of interactive system? It means that the user will require output frequently. User will require output frequently, and user will require output in fast manner, right? So in those kind of systems, the response time should be less and user should not be kept waiting. Then next is the midterm scheduler. As we told, as we discussed, it is the part of the swapping function, swap in and swap out. And the last is the short-term scheduler. So as I told you, in terms of frequency of the execution, the short-term scheduler is invoked very frequently. So the long-term scheduler executes relatively infrequently and makes a coarse-grained decision whether to take or not take a new process into the system or not. The midterm scheduler is taking a swapping decision. Midterm scheduler is taking the scheduling swapping decision, and the short-term scheduler is short-term in nature. That's why it is also executed most frequently. It is also called dispatcher. It is also called dispatcher. So dispatcher program means the short-term scheduler algorithm will determine that which process is actually executing on the processor, and this kind of scheduler, this scheduler executes most frequently. It takes fine-grained decision. So what is the meaning of coarse-grained and fine-grained? Coarse-grained means broad decisions, and fine-grained means very specific decisions, right? So like in the short-term scheduler, it has to take an absolute decision that which process will be actually executed on the processor, whereas the long-term scheduler can take a broad decision whether a particular process will enter the system or not, right? The short-term scheduler will be invoked whenever an event occurs that may lead to switch of the process, right? So as I told you, short-term scheduler's job is to execute a process on the processor. So whenever the processor becomes free, whenever the processor becomes free, the short-term scheduler has to come in the picture and take the new process, execute the new process. So in general, when we can say that the short-term scheduler comes into picture, so first is basically any kind of event which will trigger the process switch, right? Any kind of event which will trigger the process switch, it will cause the short-term scheduler to invoke. So the first kind of event is clock interrupt. At certain time period, at certain time interval, the clock interrupt happens, and the currently running process has to be swapped out, and the new process will be swapped in. So that is clock interrupt. Then IO interrupt means that the current process which is executing, it will require some IO. It will require some IO, and due to that IO request, the process will be switched. The operating system calls, some specific system calls that happens, that will cause the process switch, and finally some signals like semaphores. We will see what is semaphore later on, but any kind of operating system signal which will cause the process switch, it will invoke the short-term scheduler. So whenever there is a currently running process that has to switch, right? Whenever there is a currently running process that has to switch, the short-term scheduler will come into picture, right? So that is the long-term, short-term, and mid-term scheduler. So you have any doubts in this, we can discuss it. Otherwise, we move to next topic of actually process scheduling. Understand it very properly, because based on this, you have many other concepts. All right. So I think we should move on and continue discussing the process scheduling part. So before thinking and before going for the actual process scheduling algorithms, we should understand the process scheduling criteria. We should understand the process scheduling criteria. So these criteria of process scheduling, they are divided into different types based on the nature of the criteria. So basically the criteria is either user oriented or system oriented. The criteria are user oriented and system oriented, and between these user oriented and system oriented, again you have two more subtypes, that is performance related and others, right? So we will see what is scheduling criteria. Basically scheduling criteria means the parameter based on which you should take the scheduling decision, right? For example, I have to schedule your lectures. So what can be one of the scheduling criteria? One of the scheduling criteria is fairness. It means that all the subjects should get the same number of lectures. That is one criteria. Other criteria is your time, means that all the lectures should be given the same time duration. That may be other criteria. So depending upon the scheduling criteria, it is classified in one of these types. So let's see one by one each of these criteria. So first category we see is user oriented and performance related. User oriented and performance related. So in this section, the first criteria is called turnaround time. The first criteria is called turnaround time. It's also written as TAT in short form. So very important when you solve some examples. Now, what is turnaround time? So this is the time interval between the submission of the process and its completion. Okay, it is the time between the submission of the process and its completion. It includes the actual execution time plus the time spent waiting for the resources, including the processor. So this is the appropriate measure for the batch job. Now let's understand what is turnaround time. So let's say the process is submitted to the system. The process is submitted to the system. Uh, so we say this is my timeline, right? Let's say this is my timeline. Now at this particular time, the process P1 is submit, let's say time t equal to T0. The process is submitted to the processor. Now, for this duration of time, it is waiting, right? Now, why it is waiting? Different reasons are possible, right? One of the reason is that processor is not available. One of the reason is processor is not available. Second reason is waiting for some IO. So let's say it is waiting, right now it is waiting for the processor, right? So after that it got the processor and it is actually executing. After that it is also waiting for some time. So again it is waiting. Again it is executing. And at this point of time it got finished. So at t equal to tn it got finished. So you can see that between the time t0 and tn, between the time t0 and tn, there are certain time intervals in that the process is executing. There are certain time intervals in the process is waiting. So when we say what is turnaround time, in the turnaround time, you have to calculate each of this time interval. So when I say what is turnaround time, so turnaround time is basically Tn minus T0. That's it. Tn minus T0. So it includes the execution time, obviously, plus it also includes any kind of waiting that the process has to do, right? It also includes any kind of waiting that has to do. For example, if you are going to the college in the morning 8 a.m. and if you are coming back at 4 p.m., your turnaround time is 4 p.m. minus 8 a.m. So that many hours, 8 hours your turnaround time. But out of that 8 hours, you are studying only for 5 hours, let's say. For 1 hour you are in the lunch break, for 1 hour you are reading, for 1 hour you are doing some other activity like you are busy in some event or playing. But all these things are counted in your turnaround time. So turnaround time is the first parameter that is very important when we solve the examples as well. So understand it properly. Second is called response time. Second parameter is called response time. Now what is response time? So for an interactive process, response time is the time from the submission of the request until the response begins to receive. Until the response begins to receive. Okay. So what is the meaning of that? Let's say you double click your program, you double click your Chrome browser. So it will take some seconds, right? It will take some seconds to start your browser. As soon as you see your browser, that is your first response, right? That is your first response. So the time interval between your double click of the browser and between you see the first window of your Chrome called response time. So for the interactive processes, response time is very important. And in general also response time is very important. So we also get anxious when we click some program, it doesn't start within few seconds. We feel that the system is very slow, right? So the response time should be very less. Okay, response time should be very less for interactive processes. Then second criteria, user oriented performance related, is a deadline. So what is the meaning of deadline? Deadline is the time duration which is specified under which the process should complete its execution. Under which the process should complete its execution, right? So suppose I am given the deadline that during the during 2 months I have to complete my syllabus. So accordingly I have to schedule my lectures. If I feel that 2 lectures are not enough, I have to schedule more lectures. So that is the meaning of deadline. So deadline means you are given some time duration under which your process should complete its execution, and that kind of time duration is called deadline, and the deadline should be satisfied, and that kind of decision is taken by the user oriented performance related criteria. Accordingly the scheduling should be done. Other criteria, one of the criteria is called predictability. Other criteria is called predictability. What is the meaning of predictability? It means that the given job should run in about the same amount of time at about the same amount of cost regardless of the load on the system. Okay, so it means that once you have determined that this kind of job, this process is going to take this much time, then that time should not be dependent on the load of the system. It should not be dependent on the load of the system. You should not say that, okay, I estimate that the process will complete its execution in 5 seconds, but currently there is a lot of load on the system, so it will take 10 seconds. You cannot say that. You have to exactly determine that, okay, it will take 7 seconds irrespective of the load on the system. So that is the other criteria. It's a predictability. It means you should be able to predict that how much time your process, how much time your job is going to take, irrespective of the load on the system. Okay. Now these were the user oriented criteria, right? So if you see, predictability means user should be able to predict predict the time duration. Deadline means user has given some deadline in which the process should complete its execution. Response time, turnaround time. So all these are the user oriented goals, user oriented and performance related goals. The other type of criteria we see is called system oriented and performance related criteria. So in the system oriented criteria, our first criteria is called throughput. First criteria is called throughput. What is the meaning of throughput? So the throughput means number of processes completed per unit of time. Number of processes completed per unit of time. That is called throughput. You can see here the definition of throughput. So this is the measure of how much work is being performed, right? This is the measure of how much work is being performed, right? So if you are considering 1 second as unit of time, so you should say that in the 1 seconds, 5 processes are getting completed. So it means that the throughput is 5. Okay. So 5 processes per unit of time. So always your goal should be to maximize the throughput. Your goal should be to maximize the throughput, because as your throughput is more, you can conclude that more work is being done, right? You can conclude that more work is being done if your throughput is more. So your scheduling algorithm, whichever scheduling algorithm you are choosing, that scheduling algorithm should try to maximize the processor utilization. After that, we have uh, processor utilization. That we have processor utilization, that is the percentage of time that the processor is busy. It's a percentage of time that the processor is busy. So it is very important criteria. It is very important criteria. So what is the meaning of processor utilization? So it means that if you say my processor utilization is 90%, it means that your processor is busy 90% of time. The processor is busy 90% of time. Okay. So you should try to maximize the processor utilization. You should try to maximize the processor utilization. It says ultimately means that your processor should be as busy as possible. Your processor should be as busy as possible. It should not be free. So that is the second criteria which you should aim. The other criteria is fairness, right? Obviously, fairness is important in all the aspects, right? Fairness is important in all aspects. So fairness means uh, in absence of the guidance from the user, in absence of the guidance from the user, okay, in absence of the guidance from the user or any other system, the process should be treated same. The processes should be treated the same, and no process should suffer starvation. No process should suffer starvation, right? So basically, all processes should be treated same, and you should not give more importance to one process and give less importance to other process, given that they are of the same nature. Of course, process themselves, if they define the priority, then accordingly you can act. But if they are not defining any priority, if they are same, then you should not take your, you should not, your system should not treat them differently. And last line is important, says that no process should suffer starvation. It says that no process should suffer the starvation. Now, what is the meaning of starvation? What is the meaning of starvation? See, in general terms, what is the meaning of starvation? When we don't get enough food, uh, and we we wait for the food, but we do not get it. That's called starvation. So, in terms of process scheduling, starvation means the process is waiting for some resources. The process is waiting for some resources for execution, but that resources are not given to the processes. That resources are not given to the process, and in that uh, situation, the process waits for infinite time. In that uh, scenario, the process waits for infinite time. That is called starvation. Starvation should not happen, and if you treat all the processes in fair manner, starvation will not happen. Second is enforcing priorities. So when processes are assigned priorities, the scheduling policy should favor the higher priority process, right? Obviously. So as I told you, when the priorities themselves are defined, when the priorities are defined, then you should enforce the priorities, and the higher priority process should be executed first, and the lower priority process should be executed later on. So these priorities you should enforce. Last is balanced resources. So scheduling policy should keep the resources busy, right? It should keep the resources busy, and also keep the resources balanced, right? So this system oriented other criteria. So these are the some of the important parameters or the criteria you should keep in mind. And later on, as we are going to discuss various scheduling policies, we will see the what you say effect of each scheduling policy, effect of each scheduling policy on certain parameters, right? So as you change your scheduling policy, your parameters will be affected, and that we will see when we look at the individual scheduling policies. So in general, if your system is of pure priority based, if your system is of pure priority based, then how the scheduling happens? So this is the layout of the pure priority based scheduling. This is the layout of the pure priority based scheduling. You can see that the process is admitted. The process is admitted on the left hand side. Let me highlight it. From here, the process will admit, and you have multiple priority queues, right? So you have multiple priority queues. So for each priority, you have a queue, right? For each priority, you have a queue. For example, RQ0 means all the processes which have priority 0. RQ1 means queue for all the processes which have priority 1 till n, right? Till n, you are defining the priorities. So according to the priority of the process, it will be entered in one of the queues. It will be entered in one of the queues, right? Let's say if the priority is 0, then it will enter in Q0. If priority is 1, it will enter in Q1 and so on, right? So accordingly, it will enter in a certain priority queue. Now what the dispatcher will do, okay, what is the meaning of dispatcher? It means the actual scheduler, the short-term scheduler. What the dispatcher will do, the dispatcher will dispatch the process always from the higher priority queue. Okay, dispatcher will always take the process from the higher priority queue, because that's the meaning of priority based scheduling, right? That's the meaning of priority based scheduling. So it will always execute the process from the higher priority queue, and for example, if the higher priority queue is Q0, it will see if there is any process present in Q0. If yes, then it will execute the process from Q0. However, if there are no processes in Q0, it will execute the process from Q1. Then from Q2, Q3 up to Qn. So that is the overall idea of priority based scheduling. Other things are simple. When the process is preempted, it means when the process is switched, it will again enter its ready queue. Okay. For example, if you have decided that we will execute one process for will execute one process for 5 seconds. Then after 5 seconds, after 5 seconds, the process will basically switch. So it will be preempted. So it will again be entered at the end of the ready queue. It will be entered at the end of the ready queue. If the process is waiting for some IO, then it will be blocked. If the process is waiting for some IO, it will be blocked. And when a particular event occurs, it will be again entered in the ready queue. So this is your pure priority based scheduling. So I hope that you are basically understanding what is the meaning of the priority based scheduling. So you'll see the text description, and we'll also see the problem with pure priority based scheduling. So when a scheduling selection is to be made, the scheduler will start at the highest priority ready queue. Let's say it is RQ0. If there are one or more processes in the queue, process is selected using some scheduling policy. If RQ0 is empty, then RQ1 is examined and so on, right? So that is the meaning of priority based scheduling. You always execute the process from RQ0. If there are no processes in RQ0, then and then go for RQ1. If there are no processes in RQ1, then and then go for RQ2 and so on, right? So this is the pure priority based scheduling. Now, what is the problem with the pure priority based scheduling? What is the problem with the pure priority based scheduling? The problem is the process. Uh, the process is that with a pure priority based scheduling, the lower priority processes will suffer the starvation. The lower priority process will suffer the starvation. Now, when this will happen? When this will happen? It will happen. It will happen when there is always the higher priority process available. When there is always higher priority process available, at that time the lower priority process will always suffer the starvation. What is the meaning of this? It means that, see here, there are so many processes in RQ0. Let's say 1, 2, 3, 4, 5, 6, right? And there are 1, 2, 3, 4 processes in RQ1, 2 processes in RQN. So, see, whenever there is as long as there are processes in RQ0, you will not look at RQ1. As long as there are processes in RQ1, you will not at RQ2. So the processes which are at the lowest priority level, the processes which are at the lowest priority level, they will never get the chance to execute. So at this lower priority level, there will be starvation. There will be starvation. What is starvation? As I already told you, it's an infinite waiting, right? It's an infinite waiting. So it's an infinite waiting because it will never get the chance to execute. It will never get the chance to execute because its priority is less, and always there are higher priority processes available. So the lower priority process will not get the chance to execute. Okay. So this is the meaning of the pure priority based scheduling. Now, so we have seen the problem of pure priority based scheduling. So we should not always use the pure priority based scheduling scheme, and we should look for some alternative scheduling policies. we should look for some alternate scheduling policies, and the parameters which you should look for in the alternative scheduling policies, you should look for the parameters such as the selection function, I mean which process you are selecting next, the mode of decision, the throughput, response time, overhead, effect on the process, and starvation. So this kind of parameters you should see when you look at the scheduling. So selection function means which process should be selected. Decision mode is, we will see, preemptive and non-preemptive. Throughput means amount of work done, the unit time, number of processes executed in the unit time. Response time means the first response, the time it takes to take the first response, that is my response time. Then you have overhead, it means the overall load on the system, effect on the processes. So when you are executing the processes, which is what kind of effect is happening on the processes due to your scheduling policy. And finally, you have starvation. So starvation should not happen, right? Starvation should not happen. So that is the another parameter to consider. So let us see the decision mode, preemptive versus non-preemptive. So it is very important that the decision mode which you take when you schedule any new policy. So what is the meaning of preemptive and non-preemptive? The thing is very simple. In the non-preemptive scenario, when the process is running, it will continue running until either it terminates or it blocks itself, mean it waits for IO. It means that you cannot terminate it, you cannot stop executing it from outside. Okay, you cannot stop executing it from outside, right? So once the process starts, it will not switch until either it terminates or it requires some IO. It means it itself goes into block state. So that is the non-preemptive mode. What is the meaning of preemptive mode? In case of preemptive mode, the currently running process may be interrupted. The currently running process may be interrupted and moved to the ready state by the OS. The decision to preempt may be performed when a new process arrives, when interrupt occurs, or when the clock interrupt happens. So depends upon the policy, this decision may be taken. So what is the meaning of preemption? Basically, the meaning of preemption is to hold, right? To stop, to pause. So in case of preemptive nature, the operating system can put the process on hold even if the process is not completed. Due to any reason, the operating system is free to do this. Okay, due to any reason, the operating system is free to do this. Whereas in non-preemptive, once the process has started, it will complete, right? In the non-preemptive scenario, once the process has started, it will complete its execution. It will not be stopped in between. But in case of preemptive, after certain time duration, the process will be switched and it will be again put in the ready state. Okay. So like our lectures are the example of preemptive scheduling, right? Why? Because at the defined time interval, if I'm taking a lecture from 9 a.m. to 10 a.m., at 10 a.m., I have to stop, right? I have to stop. Irrespective of any other factor, I have to stop. So that is my preemptive nature. In case of non-preemptive, I can continue the lecture till the syllabus is over, but that's not happening. So our lectures that are scheduled are the examples of preemptive nature. Again, we can debate on which mode is better, either preemptive or non-preemptive. So again, it depends on the overall system structure, and the requirements. But in general, we can conclude that nature of the process, preemptive nature of the process is better because it will prevent the problems like starvation and infinite waiting. So preemptive nature is better in general. So preemptive policies incur greater overhead than non-preemptive because it may provide better service to the total population of the process, but it will prevent any process from monopolizing the processor for the long time, right? So it's a good thing because preemption means everyone is fair, right? Every process will get the same amount of time to execute. So no one will take less time, no one will take more time. That is why it is fair, right? That is why it is fair. So in that way, we can say that the non-preemptive nature of process is better. It will prevent the monopolizer. What is the meaning of monopolizing the processor? It means one process has taken the control of the processor for the long time. It is not going out. So that will not happen if your policies are preemptive. In addition, the cost of preemption may be kept relatively low by using efficient process switching mechanism by providing a large main memory to keep a high percentage of programs in the main memory. So we can look at these architectures and try to reduce the cost of preemption, but in general it provides some advantages to the processes, right? Okay, so now these are the in general, these are the guidelines for the process scheduling and the mode of process scheduling, that is preemptive and non-preemptive. Now we are going to learn certain operating system scheduling policies. So let's see overview of which kind of scheduling policies we are going to see. So our first scheduling policy will be FCFS, that is first come first serve. Then we will see round robin. Then we will see round robin. Then we will see SJF, that is called shortest job first. Then we'll see SRTN, that is called shortest remaining time next. And last, we will see the feedback queue policy. These are the schedule algorithms or scheduling policies which we will see in the upcoming topic. So basically, these policies are different in nature. For example, FCFS is non-preemptive policy, round robin is preemptive, SJF, normal SJF is non-preemptive, SRTN is preemptive. feedback queue. Again, it can be preemptive or non-preemptive depending upon the implementation. So all these policies are different in nature. So what we will do is we will see each of the policy with one example, and at the end of learning the policy we will see that it has a which kind of effect it has on certain parameters of the operating system. So basically, uh, one table will be given like this, that will be your process, its arrival time in the system. We will see its arrival time in the system, and then there will be one column which we call CPU burst, right, or execution time. Execution time, right? So list of processes will be given, like let's say P1, P2, P3, its arrival time and CPU burst, right? So given this scenario, this table, what is this table? So this table is rough estimation of which kind of processes are expected to enter your system, which kind of processes are expected to enter your system, what are their arrival times, okay? What are their arrival times means the time at which the processes arrive in the system, and what is the CPU burst. So CPU burst means the execution time. CPU burst means the execution time on which the time for which the process will execute on CPU. That is your CPU burst time. So based on this data, we can do the scheduling of the process through different algorithms. And after each scheduling, we'll prepare one chart, which is called Gantt chart, like this, where you will mention the processes on the vertical axis and the time on the horizontal axis, like this is the time, right? So we can mention like this, that from process P0 will P1 will execute from 0 to 1, P2 will execute from 1 to 2, P3 will execute from 2 to 3, right? Like that we can mention the time duration. Again, from 3 to 4, process P1 will execute. So this is called your Gantt chart for the process scheduling. And Gantt chart will basically give the timeline that how the processes are executed in timely manner as per the scheduling policy. So we'll see the example, create the Gantt chart, and after that we'll assess some parameters like turnaround time, the starvation factor, the waiting time, right? That we will see. So waiting time is also important consideration, because if the waiting time is more, it means that the scheduling algorithm is not very efficient. So we have to basically try to reduce the turnaround time and waiting time. Also try to reduce the starvation and increase the throughput and overall CPU utilization, right? So this is the uh, overall idea of the process scheduling. So we'll stop today's lecture here, and if you have any doubts, we can interact. And later on, we will continue discussing the different scheduling policies. So I'll wait for your queries for 1 or 2 minutes. Okay, fine. I'm closing the session.